Okay, if we have a look at this one, we've got y equals ax cubed plus bx squared plus cx plus d. And if we differentiate that, we get 3ax squared plus 2bx plus c. Now it says let m be the number of horizontal tangents. So if they're horizontal, the gradient is 0. So if we make our gradient equal 0, so there's my gradient. So that's my gradient function. So if I make it equal to 0, you can see that it would be a quadratic that I'd have to solve, and maybe I could do that. I don't have to do this, but I'll do it anyway to show you. So if I solved it using the quadratic formula, I'd say negative b, which in this case is negative 2b, plus minus square root of b squared, so 4b squared, minus 4a is 3a, and c is c, all over 2a, which is 2 lots of 3a's here. So minus 2b plus or minus, you can see that we're going to be able to factorize, I'll do it here, inside by 4, so we have b squared minus 3ac on 6a. So everything is going to be divisible. So root 4 is 2, so I'm going to have 4 b squared minus 3ac on 6a. And everything there is divisible by 2, so negative b plus minus square root b squared minus 3ac on 3a. All right, so if you think about it, really we just needed to look at the discriminant, because if it has 2 solutions, so that would mean that the square underneath the square root, so the discriminant, so that is b squared minus 3ac, it would have to be greater than 0. So that means b squared would have to be greater than 3ac in order for there to be 2 solutions. If there's just one solution, then that b squared minus 3ac is going to have to equal 0. The discriminant will have to equal 0, so b squared would equal 3ac. And if we've got no solutions, then that stuff under the square root, that discriminant, would have to be negative for there to be no solution. That means b squared would be less than 3ac. Okay, hope that makes sense.